Okay, so welcome everyone. This is the first lecture, obviously. So I was bad. I was gonna finish putting your syllabus up on the Elms page today, but I took a nap instead. So I'll do it. I'll do it sometime later today. Since I was gonna be going over that stuff right now anyway. I thought that wasn't too big of a deal if you had to wait for an extra couple hours. So the main things you probably have questions about the format, and I think I said this in my first announcement, which is all of the lectures will be live streamed. They will be synchronous, so I'm going to do it, from 11 to 11:50 Monday, Wednesday, Friday. So this now that you've seen the YouTube link, you have access to the class YouTube page. Is all of it's going to emanate from this channel, so you can use this channel as I'll probably do it once every 2 weeks. So once every 2 weeks, I will lump the previous 6 videos for lecture into a growing playlist of lectures so that you can just have them organized in an entire list, because I'm going to use this for all of my classes, so that you don't get confused. I mean, all of them will be labeled anyway, so you won't get confused regardless, but I'll put them in a playlist so that it's just really convenient. And let me go through here and see. Yes, that was a Mountain Dew. Did I miss anything else? Nope, didn't miss anything else. Okay, so anyway, so welcome. Format. There's Monday, Wednesday, Friday lecture. That's 11 to 11:50. That's YouTube live stream on this channel. And I will, like I said, I will continue to post these links. I started doing it where I would just have you all show up and I would have it, have the link be public. But I think what I'm going to do is I will make this, right now it's unlisted, although I believe you can access it with this link forever, but I will make them all public on the YouTube channel right after lecture, so they get uploaded pretty much immediately. But even before they're uploaded and they show up on the channel, I believe you can still access them from this link once they're over. So you'll have access to them like immediately after they're over. Will the notes be uploaded to Canvas? No, but I'm gonna have the videos uploaded and they're gonna be right there on Elm, so you can click on them and quickly scroll through, because everything is going to be here on the paper, so you're not going to miss anything. So that's Monday, Wednesday, Friday lecture. Yeah, this is what you're going to see. So you probably have questions about discussion. So discussions, we are scheduled, of course, to have 2 discussions, Tuesday, Thursday. You're only going to have 1 discussion a week. It's going to be on Thursday, so your discussions will be all on Thursday. And your discussion time depends on TA, so times depend on section. I'm not going to list them all out here. I'll list them all out on the syllabus when I put it up on Elms. Times depend on section. I believe a single discussion section is also 50 minutes. And so that will be held via Zoom. And you will see Elms for TA announcements. So your TAs will either use the Zoom feature built into Elms, which I actually haven't added the Zoom tab yet, or they'll just directly post you the Zoom link in the form of Elms announcements. So that's how your TA discussions will go. Now, if this were in person, of course, for those discussions you would have quizzes in them, right? So the way that the course is going to be structured here, you're not going to actually have any quizzes, so I'll go over the assignment and grading breakdown here in a second, but there's not going to be any quizzes. In fact, for the entire course, there's not going to be any strictly synchronous assignments, meaning you're never going to be required to show up at some specified time and have, some have say 10 minutes to an hour to do something. That's never, none of the assignments are going to be like that. Test format. Yeah, you don't have to worry too much about that right now since it'll be a while before your first test, but I'll still mention that here in a second. So, big note. So this is important. There will be, and I will include this in the syllabus as well. So there will be no strictly synchronous. Maybe I'll call it. So there will be no strictly synchronous assignments in the course at all. And what I mean by that is you are not going to have to, so for an exam, you're not going to have to show up to like the lecture time and you're going to only have, 50 minutes or an hour to do it. Basically, on an exam day, I will post your exam and you will have like 24 to 48 hours to do it, and then you will scan it and upload it sometime within that 24 to 48 hours. So yeah, that's what I mean by there's not going to be any strictly synchronous assignments, so no quizzes, and the exams you have are all take home, and you're going to have a window of at least 24 hours to turn them in. Do you not have discussions on Tuesdays? No, you don't have discussions on Tuesdays. So some of your TAs haven't finished giving me when their office hours are going to be. So when they do that, some of them may use the Tuesday discussion time as their office hours, if they choose. Others may use other times, but the point is that yeah, there's only one meeting per week, so no Tuesday discussions. So no Tuesday discussions. And so one reason for this is in the past couple of semesters, we found that for most of the courses that I did, there was only actually one discussion. And I think that having one discussion is right as far as the amount of engagement. There's, as I said, since there's not going to be any strictly synchronous assignments, there's technically not going to be any like assignments that are due in discussion, which is normally kind of one of the things that keeps student engagement up in discussion, is that since there's quizzes, well then you all have to go to at least some discussions. So then the point is that you should go to all of your discussions, not because there's you're not going to have assignments in discussion, but because it's going to be nice to see a lot of the. I'm not going to have time to do all of the examples that I'd want to do in lecture, so that's kind of one of the things that discussion is good at, and it's very good for all of you to go to discussion just because you don't have anything to do there. And any graded assignment that you're like handing in discussion or anything doesn't mean you shouldn't go. And I'll check with the TAs like every so often to basically see how many people are going to discussion, what the engagement level is, and if it turns out that discussion's being entirely neglected, then I don't I will say that I reserve the right to make some kind of assignment, some kind of graded component to discussions that would be not a huge amount, but would be a non-zero amount. But I won't do that if engagement in discussion is high enough. So what is the idea? So grade breakdown. These numbers aren't necessarily entirely set in stone, but this is the general idea. So there will be 3 exams. So these will be 100 each, so 300 total. There will be one final exam, which will be, I'll say 200. but I may adjust this. This may end up being like 150 or something. There will be two MATLAB projects, which will be 50 each. So that's actually, I think there'll be like 25 each. So that will be 50 total. And there will be some number of homeworks. And the sum total of homeworks will be like worth an exam and a half, basically. Okay, so I think this is more or less what I've decided on. You will have homework. So how many homeworks? I didn't say a number. It will depend. I mean, you're gonna have, we'll say 6 to 8 homeworks. So this is a part of the course that is different than it would normally be. So typically, the way that this would go is exactly the same, except instead of homeworks, you'd have quizzes that were, roughly weekly in discussion. So since I'm not going to do that, you're going to have homeworks instead. That I'll assign roughly, say, once every 2 weeks, something like that. But obviously, I will let you know when I post those. All right. Will the book, pages, chapters be released while covering material during lectures? I can mention the section numbers because I'm going to cover this in a very straightforward way, because that's the next thing I'm getting to. Is the textbook and I'll post the full title. So the textbook is Ellis and Gulick Calculus. If you've had Calc 1 or Calc 2 at UMD, this is the same textbook. So Calc 1 is the first 5 chapters. Calc 2 is chapters 6 through 10. And Calc 3 is chapters 11 through 15. So specifically in this textbook, we will cover chapters 11 through 15. Okay, so that is what is covered. So if you have a look at that textbook, like I said, it's split into 3 parts. Each one is Calc 1, Calc 2, and Calc 3. So we're the last part of the book. So it's Calc 3 is the last third of the book. Yeah, you will. No, so Alejandro, that's you'll have 24 to 48 hours to complete the exams. It's not going to be one of those things where you got a 24 or 48 hour window. But once you start the exam, you have 2 hours to finish it. It's not like that. You literally just have 24 to 48 hours to finish it. You can upload it any time during that time. Are there web assigns? No web assigns. The homework that I assign will all be from the textbook, although occasionally I could actually write my own problems, so it won't necessarily all be from the textbook. So, let me think. What else was I going to say? Oh, yeah. So, natural question that people ask is, so here's a question people ask: what is Calc 3 like? Okay, i.e., does it just start with Calc 2 or with Calc 2 material or where it left off? So rather than write out the answer, because it would take a while, I'm just going to say it. This Calc 3 is actually more similar to Calc 1 than Calc 2. So answer, Calc 3 is really Calc 1 for functions of multiple variables, right? For functions with more than one variable. And so if you were to draw up, like a dictionary or like a kind of like a comparison between Calc 1 and Calc 3, you will basically be able to map the discussions from Calc 1 and Calc 3 like one-to-one onto each other, because there's a complete correspondence between what's talked about in Calc 1 and what's talked about in Calc 3. In fact, Calc 3 is even going to end in the same place that your Calc 1 ended, right? So Calc 1, the last thing that you did was fundamental theorem of calculus. That was like some of the last stuff you did in Calc 1. In Calc 3, the last thing that we'll be doing is Stokes' theorem and the divergence theorem, which, as you'll see when we get to them, is the Calc 3 version of the fundamental theorem of calculus. Okay, they're just a little bit more complicated. And so, basically, the thing that students typically ask is, because, Calc 2 involves integration trickery. It is basically all of the more involved techniques of integration to do some really tricky integrals. So the question is, like, does Calc 3, since 3 is bigger than 2, 3 comes after 2, does Calc 3 have, even harder integrals? And the answer is no. The integrals in Calc 3 are a lot easier than the Calc 2 integrals. So there's only a couple of examples in chapters 11 through 15 in the textbook. There's at least one, and I think there's maybe two examples of integrals that are done that involve, say, something like trig sub, right? So trig substitution were like some of the trickiest integrals that you did in Calc 2, but you only have to do those. You only have to do that very, very sparingly. The trickiest thing you'll have to do in Calc 3 integrals are using trig substitutions, the double angle and half angle trig identities. That's like the absolute trickiest thing that you would have to do. And when we get to that, I'll remind you of some of those facts. Okay. Will there be a way to check the homework before we turn it in? Well, the homework is going to be mostly computational, so there exists, if you just want to say, see like whether or not you are correct, there's a lot of online resources you could use to compute the thing that you're being asked for the most part. Since there's not going to be that many conceptual things asked on the homework's going to be mostly mechanical. Let's see. Do we need to have MATLAB background for this class? No. The two MATLABs are very easy. So that's how it's done in 241. So these are easy. And when I say easy, I mean that I'm assuming that you've never seen MATLAB before in your life. And so the things that you're going to be asked to do are really, really basic, and you won't have any issue with either of the MATLABs. So that's the deal with the MATLABs. You don't have to worry about the MATLABs. Your first MATLAB will not be assigned until like right after your second exam. That's when your first MATLAB will be assigned. So you got a while. Of course, we'll be almost half over when the first MATLAB gets assigned. Let's see. Will TAs work through some of the homework problems during discussion? Yes. Yeah, they will do that. So the TAs will work through the homework problems. They will work through their own problems. They will also take questions from you. So, for the discussions will be a little bit more structured, when you show up to discussion, the TA might already have some things that they plan on talking about. When TAs hold office hours, and again, I haven't, they haven't given me the list of office hours yet, but when I get the full list, I will post those. Your TAs will remind you to. So your TAs will be in constant contact with you through Elms as well. They'll send you weekly announcements of all of the the discussion links, or they might just set up like a permanent Zoom link you just show up to during discussion time. Remember, no Tuesday discussion, so there is no discussion tomorrow, so don't freak out about that. But for office hours, when you show up to the TA's office hours, they're just gonna be sitting there waiting for questions. So you better come with questions if you want anything discussed. What's the format of the homework? It's just gonna be problems out of the book. So you're gonna upload the homework just like you would upload your exams. So it's good practice if you haven't done that already, though you've probably had to do that for multiple classes at this point. What MATLAB is in general, it's just a software package that computes with matrices. The mat in MATLAB is not for math, it's for matrix. So of course what we do with them won't really involve matrices. What you're going to be doing with Matlab is going to be stuff from this course. But it's just software package that allows you to compute various things. Nice plots. Matlab has nice plots. So you're going to plot graphs of functions and do things with functions that I give you. Let me see. Did I miss anything? Is the final cumulative? Yes, the final is cumulative. I think that gets me up to speed on all of the questions. Okay. Did I say everything I wanted to say, basically? When you start up Elms, when you go to the course Elms page, it should take you by default to the syllabus page, which of course right now is empty. But in general, that syllabus page is going to be kind of like the central repository of all info about the course. Of course, I'm going to have, I'm going to be making announcements at least 3 times a week, every week, to list out the lecture links. But as I said, the lectures are also, if you want to watch them later, you'll be able to access them immediately after lecture is over, either from the link or just by going to the class YouTube page. So I'll link the class YouTube page on the syllabus later today. So anyway, that is that. I can't think of anything else off the top of my head. I might have missed something, but it's not a huge deal. Like I said, we will make sure to hit everything as it comes along. So I think that's mostly what I wanted to talk about in terms of the syllabus. So if there's any other questions about syllabus, the stuff that I might not have mentioned, then feel free to ask as I'm going along today. But I think that's it for now. So the idea, as I mentioned earlier, Calc 3 is really Calc 1, except for functions of more than one variable. But before we can really talk about that, we have to do some basic stuff with describing space, because as it turns out, right, if I'm going to Calc 1 and Calc 2 land, so Calc 1 and Calc 2 land, when I talk about something in Calc 1 and Calc 2, I'm talking about a function, right, that is defined for a single real variable x. Of course, for single real variable, that means function is defined typically, right, on some interval. So maybe here's my interval AB on which the function in question is defined, right? And so it's a function of single variable, so it's defined on a one-dimensional set, this interval. And on that interval, the function does something, so maybe it does something like that, right? Maybe here's my function, right? So here's my f. Okay, now I don't need to do anything to describe like anything else about this function, because you've had many years of experience dealing with functions like this. But the second that I want to do something in Calc 3 land, if I want to talk about a function of more than one variable, so if I wanted to talk about a function of 2 variables, well, for a function of 1 variable, the domain in question is some one-dimensional set, some interval AB, right? But when I have 2 variables, then my domain is some 2-dimensional set. So it's a 2-dimensional region. And so really what's going on here is I have, some plane, and I'm going to draw it, of course, like this. Okay, I have some plane, and I have some region in this plane. So here's my x, y plane here. And I have some region, maybe it's this kind of like closed elliptical disc looking thing. So here's my region, I'll call this region, say, D. Okay, or actually in keeping with later, let's go ahead and be consistent, right, from day 1, I'll call this R, okay, because that's what we're mostly going to call it later. Okay, so here's my region R, and then I have a graph of some function over this region R, and maybe it looks something like this. Okay. All right, now, if you don't quite understand what it is that's going on here, that's fine because, we'll get to this in a couple chapters. The idea, though, is before I can start describing what's going on here, right? Well, I have some other axis. That's a really bad attempt at drawing a straight line. Z, that gives me a three-dimensional space where this graph f of xy lies. Right, so just like I have, a function of a single variable, so it's defined on a one-dimensional set. But to draw the graph of the function, I need two dimensions, right? I need the plane. So similarly, for a function f of xy of two variables, it's defined on a two-dimensional set, right? So a point xy is like here in the xy plane sitting inside this space. But I need three dimensions in order to draw the graph of this thing. Okay. And so let's see. To clarify, we're only going to have approximately 20 total grades. That sounds about right. Yeah, 15 homeworks. It's not going to be that many. 20. Yeah, so it's not going to be 20 then. It'll be less than that. 15 homeworks. That's way too many. It'll be more like 8 homeworks max. So it'll be something like 8 homeworks ish. So yeah, more like 13 total grades. Something like that. Sounds about right. We'll say 13 to 15-ish total grades. Maybe you'll have a nice round 10 homeworks or something, but yeah. So that's the plan. Yep, I think that's our discussions recorded. That's up to your TAs. They may not be fully recorded. Your TAs may just post notes after the fact. They may not be fully recorded because people. Various instructors, not just us, but all over, found that discussions were less likely to be super engaged if people knew they were being recorded. So discussions may not be recorded, but your TA also might. I mean, your TA will let you know if they're going to be recorded. So, okay. So anyway, well, Calc 1 and Calc 2 are in this world, Calc 3 is in this world, but you've had years of experience dealing with plotting things in the plane and dealing with stuff in the plane. But you've had very little experience dealing with stuff in space, and so chapters 11 and 12 deal with the basics of doing computations in space before we take a single derivative. Okay, so chapters 11 and 12 deal with the basics of doing computations in space. Okay. So it won't be until chapter 13. So chapter 13 is derivatives. So derivatives of a function of 2 and 3 variables. Okay. Chapter 14 is integrals of f of xy and f of xyz. Now, if you were like a grad student in math, then you might be about to have a panic attack when I write that, because technically a function is not a thing that has an integral in that sense, but we're going to ignore that. So technically forms are the things you integrate, not functions, but we'll ignore that. So chapter 15 is it's FTC, Fundamental Theorem of Calculus, for 3 dimensions, or for 2 and 3 variable functions. So it's not called the FTC, it's called Stokes' theorem. The Stokes' theorem and divergence theorem. Okay. But that's the entire structure of the course. So chapters 11 and 12, we're basically going to be doing just the basics of how to compute things in space, how to compute some basic things. Getting familiar and comfortable with doing stuff in more than two spatial dimensions. Chapter 13 will be, and so there will be an exam 1. So exam 1 will cover this. Exam 2 will cover chapter 13. And exam 3 will cover chapter 14. And the final exam will cover everything. Okay. So you might say, wait, so chapter 15 is not covered on exam 3? No, but it's covered on the final. Question is the region R visually more circular or is it more rectangular? Well, I mean, so the R can be whatever. So, if I were really just looking at like a direct analog of a 1D interval, that it would be a closed rectangular region would be the most natural analog of that. But this R can actually, again, this is exactly the sort of thing that can happen in Calc 3 that can't really happen in Calc 1 and Calc 2. In Calc 1 and Calc 2, an interval is one-dimensional, and the problem with being one-dimensional is there's no room, really. With one dimension's worth of directions, there's just not that much room for different stuff to happen, in a sense. Whereas, once you go to 2 dimensions, well, you could have a rectangular or square region. You could have circular region. You could have a region bounded, between 2 complicated curves if you want. Justin, yeah, you can watch the lectures whenever you want to. So all of them are being recorded for that exact purpose, so you can watch them whenever you want. I'm teaching a section of Honors Calc 3 at the same time, and they're going to be using these same lectures that you guys are. So yeah, this is you can watch them whenever you want to. Okay. And so to begin, right, there was kind of like one of the most basic things is like maybe I'll draw here. I have a straight edge somewhere from last semester. So let's not have axes that are too terribly unstraight. Let's do the 2D picture versus the 3D picture. For 3D picture, I don't need this. So what is the idea here? Obviously, well, if I have point in the plane, I need 2 real parameters to describe it, right? An x and a y. This is something that going to be, oh my god, I can't believe he's actually drawing this out because I've been doing this for like 10 years. But, oh, that's not right. Here's the, yes, no, that's fine. Sorry, no, that's not the way I drew it. What am I doing? This is the y, and this is the x, right? Okay. All right. And so, that's how you plot a point in the plane. How do you plot a point in space? Well, it's the same idea. You have 3 axes, right? So here's x, y, and z. And so, of course, we're having to do this, as you will come to quickly realize if you ever try to draw anything 3-dimensional on a piece of paper. The issue, of course, is that we're projecting everything onto 2D, right? Unfortunately. And so there's going to be a problem with perspective just a little bit. Especially if you're not particularly good at drawing like me. So I have point here. Now, if I don't draw other stuff, you can't really tell exactly where this point is in space. So then what am I saying? This point lies above this point in the XY plane sitting inside space. Okay. And so this point has three parameters that describe it, an x, y, and z. Okay, so the idea here is that if I similarly track where these parameters are, here is my x, here's my y, and here's my z. All right, and of course you've probably had some experience in actually drawing these things or plotting points in space before anyway, but this is what it looks like. Okay, so the question then is, what are some of the things that carry over and what are some of the things that don't? So lines in the plane, right? When I draw a line in the plane, so here's one, right? A line in the plane separates the plane into two regions. It's the region that's above the line and below the line, right? And if I'm in one of these regions, I can't get to the other without crossing that line, right? So lines separate the plane. But notice that if I imagine a line in space, it doesn't really do that. So for instance, if you look around the room you're in, you can probably identify a corner. And what you can think of is this XYZ axes you can think of as being a corner of a room, right? So if you look in the corner, this is the edge of one wall, this is the edge of another, and this is the crease going up to the ceiling, right? So if you look at this in that way, then you can imagine, right, taking a string, like a piece of string, and putting one end of it somewhere and holding the other end, holding it, tight, so that string represents like a line, right? So that string sitting inside your room is a line in space, or at least part of a line in space. And of course, the first thing that you note automatically is, that it's a line in space, but it doesn't divide space, right? There's more room to go around because we have an extra dimension. That line in space doesn't split space in the same way that a line splits the plane, right? So a line divides the plane into two disjoint pieces, but it doesn't do that with space. Because if you imagine this piece of string sitting, in space, you could go above it or underneath it, right? You could go around it. Okay, and so a line in space is not really the same kind of object as a line in the plane in that sense, right? It doesn't divide space in the same sense. And so if you wanted an object that did divide space, that has the same kind of properties as a line in the plane, then what you would look at is a plane in space. Right, so for that, rather than thinking of a string, you would think of like a blanket, right? Holding a blanket tight, having some blanket in space. And so if you have a blanket, of course, a plane, just like a line, extends indefinitely in all directions. And so a plane or part of a plane coming through your room would, intersect, all of the walls or the walls, ceiling, and floor. And so it would totally separate your room into if it's just one plane, it would separate it into two regions, right? So either left and right side of the plane or above and below the plane, however the plane's oriented. So anyway, this is just one of the examples of things that you'll be thinking about when you start visualizing some of this stuff. The z's the height. The z will always be the height for us. So yeah, z is always the height. Of course, could you, is it super wrong if you did that? No, right? You can do that instead. So I mean, this isn't like something super bad. It's just that you're relabeling things. So essentially, a relabeling is some kind of shift like that, which is fine, but it just slightly changes your picture. Okay. So, one of the first things we can discuss is like distance, for instance. So distance, how do you tell the distance between 2 points in the plane? So, right, if I have 2 points here, right, how do I compute the distance between them? So distance is the length of this thing. So if this is a point, say x1, y1, and this is a point x2, y2, how do I compute the distance between those 2 points? So remember, in the plane, distance between 2 points, x1, x1, y1, and x2, y2, is given by the following formula. So this is square root of, say, so this is, we'll say x1 minus x2 squared plus y1 minus y2 squared. Right, this is distance. Where does this distance formula come from? So someone might say it before I use the words where the distance formula comes from. But so think about where this distance formula comes from for a second. I'm going to note that actually we already had a form of the distance, not even in, so this is 2 dimensions, this is 3 dimensions. Consider distance in 1 dimension. I'm going to use a different sheet real quick. Pythagorean theorem, exactly, that's where distance comes from. So let's say I have 2 points. I'll call this x1. I'll call this x2, right? There are 2 points on the real line. Okay, what's the distance between them? Well, you might say, okay, well, when I see them oriented like this, x2 is further to the right. So the distance between x1 and x2 is x2 minus x1, right? What am I doing? There, x2 minus x1, okay, is the distance between them. Okay, but of course this is annoying because you have to include in here, okay, wait, so distance between x1 and x2 is not always x2 minus x1, because what if x1 is further to the right, right? It could be like that. Then it would be x1 minus x2. So of course the way that you deal with this is you say, okay, this isn't technically right. That's not really good. The actual distance between x1 and x2, since distance is supposed to be symmetric in the sense that if I swap the roles of x1 and x2, it should compute the same thing, right? And of course distance should be non-negative. Well, this is the absolute value of x1 minus x2. Okay. And you might say, well, that doesn't really look the same as this formula, right? But you'd be wrong, because this is actually exactly the same, because another way of writing the absolute value is this, right? So an equivalent way of writing absolute value is as the square root of the squared of the term that you're taking the absolute value of. Okay, since when you're computing an absolute value like this, you're taking the positive root, right? When you're considering this as some analytic function. Okay, when you have square root written like that, so that you actually have a function and not something that's multi-valued, right? You only care about the positive root, and so this is the same. Okay, so going back here, so the distance in the plane is given by this formula, and as people noted, this is Pythagorean theorem. You can tell it's Pythagorean theorem by just drawing this triangle. You always have this right triangle here, and of course this is just the hypotenuse of that right triangle, this distance you're computing, and that's exactly where distance formula comes from. So we can do the exact same thing in space. I'm not going to draw that picture, but our distance in space, say I have 2 points, so here's a point x1, y1, z1, and here's another point in space, say x2, y2, z2, and this is the distance, right? This line segment in space I want to compute the length of. So how do I do that? Well, the distance would be the distance between the point x1, y1, z1 and x2, y2, z2. What is this distance? What do you think you're going to do here? So note the pattern. Right, so here's the distance formula in dimension 1. Here's the distance formula in dimension 2. What do you think the distance formula in dimension 3 is going to be? Oh, well, it's x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. And that's it. Okay. All right. And so this is our distance formula in space. Of course, you might say, wait, does it keep going, right? What about 4D, right? What about four-dimensional space? Well, you know, I have a problem drawing four-dimensional space, but if we forget about, you know, wanting to draw it, then, you know, could we do the exact same thing in 4 dimensions? Of course, right? It's no problem at all. We could absolutely do that. And so that is something you could do. So the dimension between, or the distance between 2 points, say x, y, z, w, and some other x, y, z, w, is exactly this with one extra term under the radical. So yeah, and that continues for n dimensions, right? You can do this as much as you want to. Now, just some quick things that we can say here directly from this. Having the distance formula like this gave us a way of expressing things like circles in the plane, right? So let's look at, so like, you know, circle in the plane, we could write as what? Well, the idea was, what's the definition of a circle, right? The basic definition of a circle is it is the collection of all points of some specified distance from another point, right? So pick a point in the plane. That point is going to be the center of the circle. Fix a distance. That distance is going to be the radius, and you're saying it's the collection of all points that are that fixed distance. We'll call r from the point. So pick point x naught, y naught. Then the circle centered at x naught, y naught of radius r is the set of all points x, y such that the distance from x, y to x naught, y naught is equal to r. Right? But then using this fact that our distance formula in the plane is exactly what we know it to be. Right. I used x and x naught here, so this shouldn't be x1, this should be x. So that should just be x. So x minus x naught squared plus y minus y naught squared is equal to r. Squaring both sides, this means I get x minus x naught squared plus y minus y naught squared is equal to r squared. Hey, that's exactly the general equation for a circle of radius r centered at x naught, y naught. Okay, so the idea is that what is the analog to a circle in the plane in space? Well, what about a sphere in space with radius r? What is going to be the equation for that? I'm not even going to go through the same process, but from this exact same reasoning, a sphere in space is the set of all points in space, x, y, z, that are a fixed distance from a point x naught, y naught, z naught. So let's take the center to be x naught, y naught, z naught. And in that case, if I have, well, okay, I'll write it out. I have the distance from x, y, z to the center, x naught, y naught, z naught. If that distance is r, then what I get is square root of x1 minus x naught squared plus, or sorry, this again, it's not x1. This is y minus y naught squared plus z minus z naught squared. And this is equal to r, which means, of course, I get the exact same kind of equation, x minus x naught squared plus y minus y naught squared plus z minus z naught squared is equal to r squared. Okay. All right. Now, of course, just like before, in many cases, the circle that we want to talk about is one that's centered at the origin in the plane. And so in that case, this has a really, really easy form because x naught, y naught are both 0. And so circle centered at the origin in the plane has equation that looks like that, right? Similarly, a sphere centered at the origin in space has a really simple equation. Right, x squared plus y squared plus z squared, or z squared is equal to r squared. So here's circle at origin, and here's sphere at origin. Okay, so there's an example of some of the really basic stuff. Now, the first thing that we're going to do on Wednesday is go through the notion of vectors and basic properties of vectors and how to deal with them algebraically. If you've never seen vectors before, then don't worry about it. We'll discuss it on Wednesday as if you've never heard of the term in your life. And so I believe that's it. It's 11:51, so we're out of time for today. And if you want to know, kind of what it's going to look like for the rest of the semester, after I stop this stream, you can click on the link that I sent you on Elms, and you should be able to watch it immediately. It won't necessarily show up on the channel immediately. That usually takes like an hour or two, but you should be able to access it by the link. Okay. So anyway, that's that. So remember, no discussion tomorrow. You have discussion on Thursday, and we can talk more about that on Wednesday. But I will see you all on Wednesday back here. Same thing. We're gonna start on 11.2. This is basically the contents of 11.1. So we'll start on 11.2 on Wednesday. So I will see you all then.